Now that we've spent some time looking at the basic formulas of coordinate geometry, we're going to look at graphing equations. Now, when we get to equations, we're going to spend a little bit of time just talking over exactly what these things are and what their graphs represent. I've talked to you in the past about how in geometry we've got this idea of duality. We've got two different things. One is algebraic, so in this case our algebraic thing is an equation, and it's going to have a geometric representation. So on this number plane, this equation will represent something. And when we're talking about sketching a graph of an equation, that's what we're doing. We're going from an algebraic representation, an equation, into some sort of a diagram or picture, pictorial form of it. Now, algebra has an advantage in that you can do things really precisely that you can't do with a picture. It also can be a lot quicker. However, diagrams are a really useful way of representing things because they help us to understand. And throughout coordinate geometry, we're going to be thinking about equations not like we're trying to solve them, like a linear equation or something like that, like an equation of one variable. Equations where we've got two variables here, y and x, will represent, they're basically describing a relationship. They're saying that y's value is equal to or is the same as something done to x. So there's a link here between y and x, and we're going to explore that. Now the first method we're going to look at for developing a graph is going to be done using what's called a table of values. We're starting with a table of values because it's an easy method of graphing an equation, and it always works. Okay, this method is a useful method to have in your toolkit, especially as we move forward and we start to look at more and more complicated equations that we're trying to determine the graphs of. So in many ways, the table of values is really good because it's easy. In some other ways, though, this is not going to be the best method. It's actually going to be a slow method, but it's a good starting point for understanding how to draw a graph. And as we move on, we're going to try and look for more efficient ways of graphing equations. So let's get into it. This equation here is saying that there is a link between y and x. So if I pick an x value, okay, for example, let's say x is equal to 2, that's a nice easy number, then I could determine a y value by going 2 times x, which in this case we've chosen 2, and then adding 1. So if x is equal to 2, then I could say, write this down as if x equals 2, then y would be equal to 2 times 2 plus 1. 2 times 2 is 4, plus 1, then y would be equal to 5. So there's a link. This equation says that if x is 2, then y is 5. There's a link between those two numbers under this equation. Now, if I picked a different number to start with for x, okay, if x equals, let's try 3 this time. If x equals 3, then y would be equal to, okay, 2 times x is 3, so 2 times 3 plus 1. 2 times 3 is 6, plus 1 is 7. So there's a link, using this equation, between the number 3 and the number 7. And I could keep picking x values, and every time I pick an x value, I'm going to get a different y value. So that's what this equation is describing. Pick an x value, and this equation will tell you a corresponding y value. They'll be linked together in some way. Now, the reason we write it out like this is because it takes a lot of space to work out all of these x and y values. The equation is a compact version of writing all the possible numbers that we can substitute in for x. Now, this is a bit messy the way I've started writing it out here. It takes a few lines. So what we want to do is we want to explore the relationship between these two numbers, and we want to do it in a way that's a bit neater. So what I'm going to do is I'm going to draw what's called a table of values. And a table of values has 2 rows in it. The first row is going to be called the x row, and the second row is going to be called the y row. Now the X row is where I put all of these X values. So for the moment we've done a couple of them. I'm going to put 2 in here. Okay, so when we chose X to be 2, then Y was chosen to be 5. So I'll put the 5 underneath the 2 to say when X was 2, Y came out at 5. We also saw with this example below that when I made X 3, then Y was 7. So I'm going to put that in here. X was 2, X was 3, then Y was 7. And what I'm going to do is I'm going to put a bunch of different X values in. So I'll work back the other way. And I'll work in this direction. And substitute in each of these numbers into the equation and see what Y values I get out. So I'm actually going to leave the working out. I'm not going to do this kind of detailed working for all of these. But, oh, I didn't mean to highlight that there. I'm going to do this detailed working for all of these. But you could do this if you weren't sure and you needed a little bit of help. That's fine. Just do it on a scrap piece of paper to work out what the Y values would be. So let's imagine that X in the formula is a 1. If the X was 1, I'd have 2 times 1, which is 2, plus 1 would be 3. If X was 0, I put that in there. 2 times 0 is 0, plus 1 is 1. Okay. If I put a minus 1 in there, 2 times minus 1 would be minus 2. Minus 2 plus 1 is minus 1. And I could keep going down this line here. You probably can notice that there's a bit of a pattern here, but if I substitute 4 in, that would be 2 times 4 is 8, plus 1 is 9. Did the 5 in, it'll end up as 11, 13, 15. So here we have a series of numbers for Y that are based on numbers for X. And we can see pretty easily that there's a neat relationship here. Okay, these Y values are going up by 2 each time. Now, I've already said I can represent this pattern. This pattern came straight out of this equation. So this equation represents this pattern. It's a way of writing this pattern. I can also represent it as this table of values, but if we actually graph this relationship, we can actually get an even nicer way of representing it. And we're going to do that using a number plane. And the way I'm going to do this, I'm going to pair these numbers up. So I'm going to look at this one here. When X is minus 1, then Y is minus 1. So I'm going to represent that when X is minus 1, Y is minus 1 with the point minus 1, minus 1. So the X coordinate here represents an X coordinate there. The Y represents a Y coordinate. This pair of numbers here, 0 and 1, that's going to represent the point 0, 1. This is going to represent the point 1, 3, and so on. So I'm going to actually graph those points. I'm going to put little dots on the number plane at each of those locations. So let's go. Minus 1 means minus 1 in the X direction. So minus 1 would be here, minus 1 in the Y direction. That's a point there. 0, 1. Okay, 0 is my X coordinate, so I'm here. 1 on the Y coordinate is going to be a point just there. And it didn't quite go right for me. There we go. Next point, 1, 3. 1 on the X, 3 on the Y is up here. Next point, 2, 5. 2 on the X, 5 on the Y. I'm going to run out of space pretty soon. 3, 7. So 3 on the X, 7 on the Y. I'm actually going to stop there because I haven't got any more space on my number plane. I'm going to fill in some coordinates or some values on my axes. And we'll have a look at what we've got. Okay. Now it's pretty easy to see the nice pattern that we've developed here. All of these points seem to be falling in a straight line. Now, maybe because you've been trained from science, your instinct here will be to grab out a ruler and suddenly join these dots up. But before we do that, I just want to think about what we've got here. Each one of these points represents a pair of numbers that we got by substituting, I'll bring that back, by substituting into this equation. Okay, so the point 1, 3 represents that when I put 1 into the equation, I got 3 out for y. This point here, 2, 5, represents that when I put 2 in as x, then I got 5 out as y. I don't want us to lose that understanding. Now, something that this pattern implies when we start to see the points is, well, what if I picked a point halfway between these? So if I picked a point here, say at 1.5, what would I expect the y value to be? Well, if we assume that this linear pattern continued, okay, then I would expect it to be here at 4. So let's just check that that actually happens. So if I put in the value x equals 1.5, let's see what happens. Y equals, okay, 2 times x is 1.5, so I'm going to go 1.5 there plus 1. 2 lots of 1.5, well that's 3, and 3 plus 1 is 4. So indeed, yeah, that point is on also a solution to this equation. If I put 1.5 in, then I get that out of here. Similarly, if I picked 1.25 in here, I can't quite fit the 1.25 in there, I'll try my best, there we go, then we would expect a point here at 3.5. And if I put 1 and an 8, I'd get a point here. And I could keep putting points in here based on substituting numbers into this equation, and we would find that I'd have so many that they started to look a lot like a straight line. And similarly, I could go a little bit over 1.5. I could come over here and there'd be another point, and there'd be another point, another point, another point, another point. There'd be a point, sorry, I should have put them in here. Anyway, I could go to slightly more than 2, and I'd find a point here. Okay, and I could keep going. I could keep putting these points in. I could do them as close together as I like, and I would find that all of these points would start to join up, and the more points I put in, the more it would look like a straight line. And so the equation of this line, the y equals 2x plus 1, represents this here in our number plane, a line that extends in both directions forever. And that line is made up of an infinite number of points. Every single point on this line represents a value that you could substitute into this equation and get the link between the x and the y coordinates. So if I pick -3 here, that would tell me that, well, actually it's not quite there, it's down here, isn't it? It would be here. That would give me a value of -5. So if I put -3 into that equation, I should get -5 out. If I put -2 into this equation, again, my graph isn't the best here, I should get -3 out of it. So you can put any value on this x-axis, including just tiny little ones. Okay, I could pick pi if I wanted, hanging out around here, and find out what the number would be on the y-axis. But I can put any number I like on the x-axis in, and it'll tell me what the corresponding y-coordinate would be. So that's how we graph a line using a table of values. In the next video, we're going to look at how we can use some technology to actually determine these lines really quickly.